Hi NERF students, this is going to be my last video. This video is going to be a little bit longer because I'm going to have a lot in it, and so you're going to have to treat this video a little bit differently. You might want to watch it in chunks, you might want to pause it and copy some notes, or maybe whenever you're doing some questions you might want to fast forward to the different parts. The last chapter that we're doing is systems of equations, so I'm going to go over that today. Also, we kind of toyed around with the idea of doing like a summary of all the topics, but I decided against that. So this is going to be the last video, and the assignment that you're going to get is going to be the last assignment. And all online learning is done on June 12th. So you're going to maybe have a little bit busy week trying to learn some stuff from this video, but then your last assignment and you're all done. Okay, let me jump into it because it's going to be a long enough video as it is. Okay, let me go. We are going to talk about systems of equations. That's when you have two lines drawn on the same graph, and you want to find where those graphs overlap, or where the graphs meet, or like I say, the point of intersection. So we're only going to do it for two lines on the same graph, but in Foundations 11 I actually just did their review video, and they do 3, 4, 5 lines on the same graph. Now, the very, very basics, so it's a good idea to review how to graph a line too. But there is a graphing method. That's the one I'm going to show you first. And like I said, you might want to pause and try a couple of those questions. There is substitution and comparison. I don't know what order I'm going to do these in yet. I guess I'll just go by my slides. I might do comparison first. They're pretty much the same thing. And this is a popular way to solve a systems of equation. And then there's another way called the elimination method, and I'm going to show you that one too. These are all ways to solve a system of equations. Now, a lot of times I don't like to show 4 different ways, but they all have good points and bad points, and so that's why I'm going to teach you. But the truthfully is, whenever you get, like on a normal year, when you get your test, you could pick what method you want to use. Some people are like a one-trick pony, and they pick the same method and use it every time. I would say probably the most preferred method teaching grade 12s is the elimination method, with substitution method being a close second. The elimination method is good. It's a little bit harder to wrap your head around, but once you get it, it works for everything, no matter how hard they are. So if you're dealing with fractions or decimals or that kind of stuff, the elimination method, some people prefer the elimination method. So I'll just put that in the back of your mind, but you can pick your own favorite. And obviously it's not a normal year, so we're going to be doing things a little differently anyway. Okay, so now I'll get back into the graphing method. So the graphing method is you're going to have two lines, and you want to find where those two lines intersect. So basically, what point this line and this line have in common. So what I'm going to do is graph them. This one here, the slope is -1. Remember, there's a 1 in front. And then your y-intercept was 8. So I went all the way up to 8. Here, I'm just going to get a pen out here, I guess. I'll get green. So I went all the way up to -8. And then I went down 1 over 1, down 1 over 1. And that's how I got that line. For the next one, I had a y-intercept of -2. Yes, I gotta move this a little closer so I can reach my board. So I have a y-intercept of -2, and then the slope was up 1 over 1, up 1 over 1, up 1 over 1. So all the time there. Second, my alignment was off. Now, where these lines intersect, that is called the point of intersection. And you can see easily on this one here, it intersects at the point 5, 3. So if I put x was 5 and y was 3 for both of these graphs, they would be equal to the same. If I put x as 5, it would be equal to 3 for both of these graphs. So here's another one, and just for the sake of this video, I did them out already. So I have a y-intercept of -2. So y-intercept of -2. Slope was up 1 over 2. Maybe I should have made an up sign. Up 1 over 2. So I went up 1 over 2, up 1 over 2, up 1 over 2, and so on. Drew that line. The next one, the y-intercept was negative or positive 4, so that's where this point came from. And then this time I went down 5 over 2. So down 5 over 2 gave me that point. Down 5 over 2, that's how I would draw those lines. And then the point of intersection. All lines will intersect unless they're what? Anybody know? Starts with a P. Parallel. So parallel lines will never intersect, but any other sets of lines might be way off the graph paper, but I'm going to pick ones that do intersect on the graph. So you look for the point of intersection. Usually that would be one day. Like I would stop, I would get you guys to graph a whole bunch and then find the point of intersections of them. So this might be a good place to pause the video, go practice some graphing ones. I am going to go on to this next method. It's called the comparison method. Now the comparison method is a special type of substitution method. It only works when you have two equations that are both y equals. So I got y equals this, y equals that. So this is called the transitive theory. Like this is just talking it through. Like if I said if a equals 7 over here and a equals b, if a equals 7 and a equals b, then you know that b is equal to 7. So same thing over here. If we know at y is equal to, I'm going to just write out the word this, and y is equal to that, then this has to be equal to that, because they were both equal to y. So you'll notice that we said this is equal to that, and there's no y's, there's only x's. So you can solve for x. So you bring all your x's over to one side and all your numbers over to the other side. This was a negative x, so I brought it over here. And I had 10 equals 2x, divided both sides by 2. I get x is equal to 5. So that is this point right here. X is equal to 5. That is, if I was to graph it, that's where it would cross for the x's. And then to figure out for the y, then all I do is I substitute x is equal to 5 into one of the original equations. It looks like I picked the first one up here. I'm just using my work from another year. But what I did is I took that equation, and wherever I had an x, I put in negative 5. Oh, not negative 5. Oh, it was negative x. So it was negative x, like y equals negative x plus 8. So I have to say y equals negative 5 plus 8, and then I got 3. So the point, if I was to graph it, you would see that it crosses the graph at 5, 3. This is one I did graphing and comparison, just to kind of see the difference. So I have the graphing one here. Where is it here? Oh, I guess I got the graphing on the other side. Graphing and then comparison. Let me just get rid of this extra stuff here. Okay, so this one's comparison method. So y equals this, y equals that. I'm going to set this and that equal to each other. So 5x minus 1 equals x plus 3. I'm going to solve for x. So I'm going to bring all the x's to one side, all the numbers to the other, and I get 4x equals 4, divide both sides by 4, and I get x equals 1. So that's what x is equal to. Now, I really could substitute it into any one of them, doesn't matter. I usually ask a student. So let's say that Graydon told me to substitute into equation 1. Okay, so I'm going to put x as 1, so 5 times 1, take away 1, gives me 4. That would be the point 1, 4. That's using comparison method. This one here, this looks like I did that twice. Let me just erase that. I thought I had it on here, but let me just graph it real quick. So the y-intercept was negative 1. Can I reach? Move it over and just Bear with me for a minute. Okay, let's try. So the y-intercept was -1, and I had to go up 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Over 1. 4, 5. No, I counted too many. Like, it's harder trying to do this. So there's 1, 2, 3, 4, 5. So technically on the 4 place. So up 5 over 1. And then I like to go to draw these. I'll go down 4 or 5 over 1. 1, 2, 3, 4, 5. Back 1. That's how I would draw that. And I'm not going to use my ruler just because I don't want to take up too much time. So there's that one. The second one had a y-intercept of +3. And the slope was 1. So technically up 1 over 1. It's easy to do this. Down 1 over 1. It's easier to see that line. And then like that. And then this point right here would be 1, 4. Which is exactly what I had here. So graphing method or comparison method. The pros and the cons. Graphing method, you need graph paper. So that's kind of a problem for a lot of people, especially if you guys are home and don't have any graph paper. Graphing method only works good whenever it's exactly on the points. So like 1, 4. If it had been like 1.3, 4.7, like in the space of the grid, it's really hard to see. Like you need to do the calculation instead of trying to eyeball it. Here's another example of comparison method. So y equals this, y equals that. I set them equal to each other right here. Okay, that's just that question worked out. Okay, the next one, I'm just going to go to this other slide here. It's called the substitution method. Now the substitution method is a very popular, I'm going to say in popularity, I might say second most popular method. Some people use this one all the time, and that's okay. Substitution method works good, especially when one letter, you can only get one letter by itself. So just like we had to do in the last chapter, sometimes you have to rearrange the equations. So I'm looking at these two lines, and like that x is not by itself, this y is not by itself. This x is by itself, well, not quite by itself, but it's easy to get by itself. So what I did is I took this x and I brought the 4y over to the other side. So we know that x is equal to -4y take away 6. And they call it the substitution method because we know what x is equal to. So we can substitute that in for x. Like it's supposed to be -3x equals 4y plus 2. So I put x is -4y minus 6. Like I just put that right inside where the x is. Now a lot of times there's brackets, so I'll get rid of the brackets, multiply it out. We've got only y's. So I'm going to get all the y's by itself. Divide everything by 8, and I get that y is equal to -2. So let me just say that again. This is brand new. Normally we would spend a whole day on this. So if I have any set of equations, and it's easy just to get one letter by itself, I do that. And I substitute that letter into the other equation. Get rid of the brackets, solve for the letter that you have. This time it happened to be y. Then your next step is to take that y equals -2 and substitute it into one of the equations. Doesn't matter, you could be the first one again. So I put it back into the original equation where y was -2. And then this time I'm only going to have x's, and I can solve for x. And then I get x is equal to +2. So pause it if you need to. Copy down the notes. Maybe you might even need to listen to it again if you need to. Okay? But I am going to keep going on for the sake of this video. Here's another example of comparison method. I'm not going to talk too much. You can pause the screen. Can I get rid of that? I'll just minimize that. Okay, so you can just pause the screen if you want to. I got both of the y's by itself and solve for x, and then you would just plug that x is equal to 1 into one of the equations. Okay, the next one, like I said, I would probably spend a whole day on substitution method. Now, elimination method is one that I usually spend 2 days on the elimination method. Elimination method, or sometimes people call it the addition subtraction method, is when you rearrange terms so that the terms are stacked. So that means the x's are on top of the x's, the y's are on top of the y's, the equal signs are on top of the equal signs. And then you treat it like old school addition and to eliminate a variable. So, for example here, I have 3x plus 4y equals 10 and 6x plus 2y equals 14. Now I got to decide if I want to eliminate the x's or the y's. Usually just whatever one's easiest. In this case, they're both pretty easy. By the look of my answer key over here, I decided to eliminate the x's. A lot of times I'll ask the student which one do they want to eliminate. So these x's aren't the same. What I'm going to do is I'm going to multiply, like this is an equation, so long as I do the same thing to every term. So I'm going to take this equation here and I'm going to multiply it by 2. That's what I did over here. So it's going to become 6x, it's going to become 8y equals 20. Now notice everything is stacked up. X's, y's, equal signs, numbers, and the x's are the same. They're the same sign. So if they're the same sign, what I can do is I can subtract them. So I'm going to take equation 3. I kind of got them named over here so we can follow along. Equation 3, subtract equation 2. So 6x take away 6x is gone. Like they're eliminated. That's why they call it the elimination method. 8y take away 2y is 6y. 20 take away 14 is equal to 6. Divide both sides by 6 to get the y by itself, and you get y equals 1. Then I always ask one of my students to pick an equation, either the first one or the second one. Looks like they picked the first one. And so they're going to substitute 3x plus 4y. Here we found y was 1. So 3x plus 4 equals 10. And then that gives me my x value. So you already knew your 1 right there. And then you found your 2 by substituting it in after. Like I said, this is one that we usually spend a lot of time on, so you might need to rewind that, listen to it again. I'm going to do one more example. I guess it's back here. Here, this little tip that says if the signs are the same, you subtract. If the signs are different, you add. This one here was a little bit easier because the x and the y were both 2's. We didn't have to change anything here. So the signs are different. That's a plus and that's a minus. So if the signs are different, you add these together. Because 2 plus a negative 2 just makes 0. Like they're going to eliminate each other. I'm trying to do x here, but it's not working. Okay, they're going to eliminate each other. 9 plus y is 17. Just happens coincidence equal to 17. So divide both sides by 17, you get y equals 1. And then you substitute, this one's not finished, but you would take that, substitute it into one of the other equations, and that will give you your x value. So we know 1 is the y value. Let me just do it real quick in my head. 2x plus 9 times 1 equals 1. So that would be 9. Bring it over the other side would be negative 8. So 2x equals negative 8. X is equal to negative 4. So, like I said, I did that a little fast. Let's see, what else? Solve by any method is a couple examples that I did. What I like about this one is the y is already by itself. So I would use substitution method. Like this y is already by itself right here. So in the second equation, I would substitute the first equation into the second equation. Wherever there's a y, I put in this negative 3x plus 9. There's only x's, so I solve for x. Then I solve for y. This one here, I got everything's all stacked up. nothing. I could get the y by itself and do substitution method, but what I decided to do here is just get the x's the same. So I doubled. I took the first equation and times it by 2. Signs are the same, so I subtract. So 2 take away a negative 3y makes positive 3y. Makes positive, and so then you get y equals negative 3. You substitute it into one of the originals, doesn't matter. They look like whoever picked this one. Let's say I picked beta, and she said, okay, put in number 2, and then you can solve for the x value. Okay, I'll just make that smaller, and maybe if you want to take a screenshot. So that's an example of substitution method on the left, and number 2 is elimination method. Here's an example of elimination method. I'm just going to go through them, pause them if you want. Here would be just a good example of when I would use each one. Like graphing method, if they're both y equals and I have graph paper, then I would probably, this would be a good candidate for graph paper. Comparison method, if they're both y equals and I don't have graph paper, then I would set this equal to that and then solve. Substitution method, I use that one when traditionally I'll use that one when I got just one letter by itself, and I would substitute that in. And then elimination method I would use whenever you have to, when they're all stacked up. Now notice I have the x's or the y's, like the y's here are already stacked up. So I would do subtract, and I would eliminate the y's, I'd solve for x, and then I would put that back in to solve for y. There's all kinds of other videos. Maybe I'll even try to find a couple links on YouTube, and I'll give you some practice questions, and then I'm just going to give you a pretty simple assignment where I'm going to give you a couple of systems, and I am going to ask you to do one graph paper graphing method. If you have graph paper, great. If you don't, you're just going to have to try a little bit harder to accurately draw it so you can see the solution. But then for the other ones, you don't need graph paper, and really you could pick whatever method you want, but I'm probably going to get one that's kind of designed, like suggested to use comparison, suggest to use substitution, suggest to use elimination method. Okay, that's my video for today. This is probably going to be your toughest one because I'm putting a lot in one video, but you know, check in with me, check in with Miss Sears. I'm going to try to find some other YouTube links. There's other stuff on the web that's great. A couple practice ones, and I will get like one assignment, and it's going to be due on Thursday, and then you're all done. Okay, have a great day.